Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. When HBr is added to an alkene in the presence of peroxide, radical initiator, the reaction proceeds via a free radical mechanism, anti-Markovnikov addition, rather than the ionic Markovnikov mechanism. Moving on to the next step. Identify the reaction conditions. The reagent is HBr with C6H5CoO to O2 benzol peroxide, which is a radical initiator. This triggers free radical addition of HBr. Moving on to the next step. Recall the mechanism of free radical addition of HBr. Benzol peroxide generates radicals that abstract H from HBr, producing a bromine radical, Br. And for the final step, the bromine radical adds to the less substituted carbon, terminal carbon, of the double bond in propene, CH3, CH is equal to CH2, generating the more stable secondary carbon radical at C2. This is because Br adds to the terminal CH2 to give the secondary radical at the internal carbon. The secondary carbon radical then abstracts H from HBr, giving CH3, CH2, CH2, Br, 1-bromopropane, as the product. This is anti-Markovnikov addition. Br ends up on the terminal, less substituted, carbon, which is option A, CH3, CH2, CH2, Br. Why other options fail? Option B, CH3CH, Br, CH3, to bromopropane, is the Markovnikov product formed under ionic conditions, no peroxide. Option C, BrCH2, CH is equal to CH2 would require allylic substitution, not addition. Option D, a bromocyclopropane requires a different type of reaction entirely. Therefore, the correct answer is A. Therefore, the correct answer is option A.